Awesome. All right. Very well. After a long gap, we AccuKnox are back again, doing a series of 10 episodes of TGIT, which means thank God it's Thursday. We have awesome topics aligned. All are like super hot, latest happenings in the security business in general. So the topic that we selected as the episode 1 is zero trust agentic AI security. So we have been joined by Rahul, who is the CTO co-founder of AccuKnox, a very renowned and leading voice in the cybersecurity and the cloud security in general since the past 2+ decades. And we have a bunch of key agenda areas which we will be covering, starting from what is AI agent, as simple as an understanding for all of us, demystifying the concept, number one, and number two, understanding the threat landscape in general, like what are the key agentic AI threats that is coming along with the technology advancement, wherein security becomes imperable. And number three, AccuKnox's solution, which showcase what we've built, how we've made the UI UX as simple and easy to understand. So we plan to keep this very, very short and interactive as well. Please feel free to use the comment section. Do drop your questions any point in time. I, being the moderator, will ensure to get your questions answered with Rahul's expert advice. Great. So with that being said, Rahul, over to you.
Pleasure to be here, Syed, and to do
Yeah.
this, the first episode. Yeah. So it's good to see, good to talk about AI agent. It's very topical. But let me just define the AI agent for the audience here. Uh, an AI agent is no different from any other enterprise application with the following caveats. On one side, it has access to large language models, and on the other side, it has access to the tools. And it can also leverage memory. Put these things together, it becomes an extremely powerful combination. That's what AI agent is able to achieve, and we'll show you some of the example use cases and some of the threats in the context. That's basically the nature of an AI agent, where more and more applications are getting driven by large language models, and those applications have access to other toolings. These are essentially AI agents, and there are multiple design patterns when it comes to AI agents that one can have, and we see a lot of organization experimenting with these different patterns.
Got it. All right. So, Rahul, please walk us through again from the Security 101 of AccuKnox since the past 5 years, the portfolio of products that we've built, starting from AppSec till the topical AI security today. So,
Yeah.
a
So
refresher would be great.
fantastic. So 5 years back when we started, we looked at primarily the workload protection platform. That's where the runtime security engine that we developed, called as KubeArmor, played a pivotal role. Uh, but when we got information in the context of runtime security, we felt that, hey, this information could be leveraged into other contexts as well. But to leverage this information, the runtime information in the context, other context, we need that information. We need the data sets in the context of those dimensions, such as cloud, application, Kubernetes, containers, and so on and so forth. So that's where we decided, like, for 2 years back, we decided that we have to operate as a platform. Security is done best when you have the most context. uh, the context leads you to then doing better prioritization, better remediation. Seldom is a security remediation handled at a single dimension. It requires you to have visibility across multiple dimensions, and that was our aim when it comes to platformization. So today with AccuKnox, we have visibility into everything from code, uh, to container images, to cloud, to clusters, be it virtual machine clusters or Kubernetes clusters or serverless workloads. And then AI security, right? Like, where now more and more model based applications are getting prevalent. These model based applications, essentially called as AI agents, we see most of the organizations moving towards these models. And in fact, AccuKnox was one of, we started using AI agents within AccuKnox itself, and that's when we realized, hey, these agents, if someone is able to attack these agents, the damage is much higher than traditional enterprise networks, because the nature of AI agents is to have access to these interesting tools. So that's where we realized, yeah, SPM is going to be the need of the hour, and we worked upon getting visibility. The first in when it comes to security, the first order of business is getting visibility and observability in the context. What models are deployed, what data sets are present, which training jobs are using, what kind of data sets resulting in what kind of models. That information is required, and then comes, hey, once these models are identified, how can you tell the security team that these models are safe to be used in the target environments? These models do not contain these guardrails and thus require prompt firewalls placed in front of them. Having said, prompt firewalls is a great solution, but then what happens if an attacker is able to compromise the prompt firewall? What is the next level of protection as an organization I can put in? So all these questions came trickling down automatically, and then, some of the compliance frameworks were a big uh, they basically unfolded as the whole platform. The compliance frameworks such as NIST AI RMF, ISO 42001, they gave us a methodical way of looking at the problem statement, and today what we have is the full platform in everything from
Right.
code, cloud, containers to clusters.
Awesome, awesome. So Rahul, before I move to the next slide,
Hmm.
talking about the AccuKnox's approach, like the value prop and let's say unique differentiation, which every customer of AccuKnox today, it's been intrigued, and that's what we get frequently asked about.
Hmm.
So talking about our solution in place in terms of let's say stopping against hallucination, prompt manipulation, or let's say code abuse. So just wanting you to touch upon
Right.
a few high-level data points, and later which you can do a demo as well of what
Yeah.
you are talking right now.
Right, right. Let me just state what is it that the customers typically ask, or the users typically ask, right? Like the questions that typically the customers are asking, or the security teams are asking, is the following. My In my organization, we have AI application developers, and they are leveraging models. And how is it that I come to know as a security team what these models are, what the data sets that they're leveraging? Do the data sets contain certain key PI or PHI information that the organization might not be comfortable pushing it to the AI model training? The second order of business is, how many of these models are safe to use? Now, this is an incredibly difficult question to answer, essentially because uh, models are essentially black box, right? Like you can't really look into it, right? Like unlike open source code, open models, these are a bunch of set of weights and biases. You can't really look into those and say, hey, this seems safe, this doesn't seem safe. So static scanning tools yield very trivial findings, which are not very helpful. So that's where model security comes into play. The ability to do automated red teaming is a key important aspect, in my opinion, where you try to figure out what kind of guardrails are present on the model security. uh, the second aspect of model security is untrusted models execution. In most cases, AI application developers are not developing their own models, or most of the organizations are not developing their own models. They are picking the models from some public sources, such as Hugging Face, and there have been papers. There have been Hugging Face itself has called out multiple times that these models are coming from untrusted sources. This could contain triggers in the form of prompts, which might initiate an actuator inside the model itself, which can then create a reverse shell, or could send an internal information, or the data sets exploited to the outside world. It could be anything. It could be based on an image that the end user pass. So untrusted models execution is another big problem. uh, Furthermore, we see that a lot of organizations do not want to use models that are deployed, or SaaS hosted models. The nature of their business is that their information, their IP rights, their code is extremely confidential. They do not want any of these models to have access to this information. So how do you ensure that you deploy these models locally, some of these models locally, and in a safe way? That's another big problem statement that we come across. Then there are standard aspects, right? Like your AI models, your AI application, agentic AI, MCP servers are nothing but finally an enterprise application. So you still need to have everything from infrastructure security to application security to container security. I do not know of anyone who is deploying AI in a non-containerized models. It's frankly speaking, it doesn't make sense to me. Everyone is deploying AI in containerized model either, and some of most of them are using orchestrated solutions such as
Hmm.
Kubernetes. And the abstraction that Kubernetes gives is amazing in the context, but that abstraction also leads to unknown security risks that an AI application developer might not be in a position to anticipate. That opens up a lot of attack surface, and that's where some of the work that we are doing in AccuKnox is helping our customers to foresee first and then do something about it.
Right, right. Wonderful. So now, one more question with respect to, let's say, the black box mode and not getting visibility inside the AI open AI models, etc., etc.
Hmm.
Like, what does AccuKnox add value in this context? Like, giving, let's say, 360-degree overview
Hmm.
of the datasets model and the runtime posture. So I'll probably stop sharing because the
Yeah,
proof of putting.
yeah,
Yeah, yeah,
I'll give you an
yeah,
example, right? Like
yeah.
before I
Mhm.
start sharing my screen,
Sure, sure.
I'll tell you a case study. We created a malicious model ourselves. Okay, that malicious model internally contained a trigger that gets activated when a specific prompt is sent its way. Okay, uh, and now this model was deployed on top of Olama internally within AccuKnox, and we said our red team to actually do any kind of scanning. You do whatever static scan you can do to check whether you can figure out what the problem is, or we're telling you beforehand that this particular model contains issue, but we won't tell you what exactly that is. Once it is deployed in the target environment, as an external user, I'll be compromising that particular model. And there is basically no way for the red team to say that, hey, we did the scanning of this gguf file and we are able to see this particular attack surface. It was absolutely not possible. So that's where, you know uh, as an outsider, we were able to actually push a prompt that enabled the trigger, that set off a trigger that enabled a reverse shell to that particular workload within the model itself. And then now we had external access to that reverse shell, and we were able to penetrate the system, right? Like, it's as simple as that. This is an extremely important problem, because you started off by saying that these are black boxes, or rather I
Mhm.
also mentioned this in the that
Yeah.
it's a black box. The problem with the black box is you don't know what kind of malicious triggers that might be, and if you're procuring this black box from untrusted sources, you have to be very careful. Now, it's not just AccuKnox. Every single inference engine, including TensorFlow, PyTorch, Kubeflow, uh, everyone calls this out, saying if you are deploying untrusted models, you better be deploying it in a sandboxed environment, because you will never know what it contains. Fantastic. So now what we are looking at is the platform supported, and again, this is a very important topic, because the managed platforms, the unmanaged platforms. Here, most of the in this case, what we are seeing is Amazon Bedrock, which is a platform, which is a managed platform. Amazon's, which is a managed platform for large language models. Amazon's SageMaker is an umbrella platform, which basically includes both predictive ML models as well as large language models. These do not natively provide large language. Bedrock provides foundation models in the form of Titan Text, G1 Lite, and things like that. There are certain foundation models that are natively provided by Bedrock. OpenAI has almost everything now. It has large language models, it has agentic AI SDK, it has codecs, it has coding tools and things like that. Hugging Face is purely a repository, the models and datasets repository. Google AI Studio, again, is an important and interesting way of managing the AI artifacts, including predictive ML models, large language models. Vertex AI is specifically focused towards Gen AI models. Yeah, so Vertex AI is an Amazon equivalent of Google for large language models.
Mhm.
Right. So
Got it.
yeah.
Got it. Yeah, probably, Rahul, with respect to like the deep dive of the product that
Hmm.
you'll be doing,
Right.
would you please cover the red teaming use case and also the prompt firewalling use case? These are the let's say most frequently asked questions during my time in the diet text as well last week. Hey, can AccuKnox do defend against the data poisoning, prompt injection, and also let's say red teaming? So yeah, probably it would be great if you can cover this
Absolutely,
again. And
absolutely. Let me
yeah,
share my screen. What I'll do is share my screen and then show you
mm,
the AccuKnox solution in the contest. Bear with me for a second.
yeah, screens flashed.
Okay. Okay. So what I'm going to show you is the AccuKnox enterprise product. And now this enterprise product, like we discussed before, right? It contains everything from cloud security to code security to runtime security to AI and application API security. All of these models are part of the solution. So I'm specifically looking at the AI ML security. So here you see everything from AWS, Azure, GCP, as well as on-demand scanning. So if you have Olama, VLLMs, AI Studio based models deployed locally in your environment, we should be able to show them as well. And the combination of both, not just limited to large language models, but even predictive ML models, right? Like we are able to identify what models are deployed in the target environment. And this provides you a 360-degree view. You have models, data sets, you have AI ML specific issues, you have infrastructure specific issues, all of this populated in the uh, same dashboard. The important thing is for the security team to know that, hey, this compute instance is publicly accessible, and it's a risk to actually deploy an AI model on top of it, right? Like that kind of visibility the security team needs. But in this particular conversation, I'll focus upon large language models and predictive ML models and show what is it that we do. So here we have a lot of models that are deployed, roughly 100 models that I have deployed in my tenant. I'm going to specifically show you some of the red teaming, right? Like what happens is that as a, you know, users are deploying models all across multiple regions, right? Like you see Titan Text G1 Lite is one of the popular model used within AccuKnox, and it's deployed in AWS Bedrock. And US East 1 is where I operate personally. And you'll
Hmm.
see the details of this particular model. We see that it is deployed. And how do we know it is deployed? Based on the pipeline view here. So we know that this particular model is a foundation model on Bedrock. We have the details of that model. This is deployed in this particular region, in this particular account. All that information is naturally present. But more importantly, we know that this model is served by this particular endpoint. This is the HTTPS endpoint that is serving this particular model, which means that this model is reachable, and hence it is called as deployed model. Once we know that the model is deployed, we start doing automated red teaming. The aim of automated red teaming is to understand what guardrails are present on those models. So in this case, you can see that some of the probes have failed, some of the code related probes, hallucination related probes, prompt injection and sentiment analysis related probes have failed. I'll walk you into one of the probes and then show you what that probes actually means. So in this case, what we are looking at is we are asking the large language model to write a malware payload. And in this case, what you'll see is, hey, we have asked it to write a code for code injection in x86 language. So it basically started it gave an output where it started giving uh, data in the context of generating malware code. Now if imagine if Titan Text G1 Lite is used for code generation, this would be an extremely critical risk. It would be an extremely critical risks to use it in the agentic AI application for code generation. So that's what the primary aim of automated red teaming is. This is where we come to know what guardrails are not present on the target models. What is the security team going to do next once it figures out that these guardrails are not present? The immediate next thing is, can we add an external guardrails? Like, is there a way for AccuKnox to add a prompt firewalls in front of it? So then what happens typically next is we look at prompt firewall as one of the solution to be used. So I'll show you what happens next. So so we see that there are a bunch of applications here. These applications are using those large language models, and we then say, hey, this application is a code generation application. So it would require the prompts and the response to be scanned and checked whether malware related code is not getting generated. So here you'll see a bunch of policies. This bunch of policies are applied in this context of this particular workload, this particular AI agent application. And the prompt firewall operates essentially as a proxy where all the prompts and the responses are sanitized before they are shipped back to the users. Here you will see two types of information. One is monitored prompts and the other is block prompts. So you have the ability to specify as a policy whether it should the action is monitor or block. What is the scanner type, whether the scan happens at the prompt level or at the response level, and what is the policy type, right? Like whether whether it's a sentiment, ban competitors, or toxicity. And you'll see the detailed policy types mentioned here. These are all the policies that are present for prompts. These are the different policies that are present for for responses. The primary aim is that once you identified that these guardrails are not present, you would want to use prompt firewall in the context of those models. That's the fundamental aim here. So typically what we have done here is we have gone
Mm-hmm.
beyond the ask of just scanning the assets on the cloud infrastructure and giving visibility to the users. That is important,
Mm-hmm.
but we have gone ahead and said, hey, these models are deployed, let's do red teaming in the context of these models. We have the context of the red teaming. After the red teaming is done, what is the security team is going to ask? This red teaming typically yields you risks in the context of the corresponding deployment or the models in this case. So once you know the risk, you need a contingency plan there. You need the second level solution to actually secure those risks. That's where the prompt firewall comes into play, and so on and so forth, right? Like, so we have the full story knit together as part of the platform. Everything from visibility, automated red teaming, to final policy based security. And we don't stop there, right? Like, we go to the next level where we say that prompt firewall cannot be the final solution from the security point of view. Prompt firewall could still be bypassable, it could be still circumvented using enough prompt engineering. And that's where the sandbox execution. So we have we have KubeArmor as a policy engine, which essentially allows us to do sandboxing of the AI agents, MCP servers, or untrusted local models. And we are able to do that as part of onboarding of the Kubernetes clusters. We identify what agents are deployed and then sandbox those agents as part of the solution. So it's a full 360-degree solution put together.
Got it. Now, we have 7, 8 minutes
Hmm.
left, and before we wrap up, one another frequently asked question is, hey, the
Yeah,
roadmap. What's next in the AI security feature functionalities that you have planned in a macro level? So, anything that you're excited about?
absolutely. I'm very
Yeah.
excited about multiple things here. One is we are adding in support for some advanced frameworks out there, such as RunAI. So NVIDIA RunAI, NVIDIA NeMo, NVIDIA NIM services. You'll see some policy templates, out of the box policy templates from AccuKnox. We see this a lot of these a lot of organizations, especially on-prem deployments. NVIDIA benefits a lot. NVIDIA related ecosystem benefits a lot because you have you have all the components, from everything from large language models deployment to predictive ML models deployment to orchestration solution provided as part of RunAI. But at the same time, we see a lot of risks. Like, these are multi-tenanted shared infrastructure that customers use. And Kubernetes, the nature of Kubernetes is that by default it doesn't have any security applied. It's not secure by default. People usually talk about, hey, we have our applications segregated into different namespaces, but what they don't realize is that namespaces are extremely soft isolation. They are very fragile isolation mechanisms. It's very easy for an attacker to, if the attacker somehow manages to get privileges uh, on the Kubernetes environment through anything, right? It could be supply chain attacks, or because of vulnerability, or because of zero-day attack. It could be anything. Once they are able to get privileges on one of the workload, they could easily dig into other workloads on the same environment. It's very simple to actually circumvent the namespace isolation of Kubernetes and move into other namespaces as an attacker. And these are some of the interesting stuff that we are working on. We have already shown these aspects. The other aspect that we are looking at is model poisoning. And we have done some interesting work there where we have shown how models could be poisoned. Uh, I think one of the key work that any security team has to do is to actually simulate these attacks, right? Like, people talk about model poisoning, they have been talking about model poisoning for a long time. But to simulate a model poisoning attack is non-trivial. So we said, what is the attacker going to do? How is the model going to be poisoned? At what all different stages are the models going to be poisoned? The multiple ways to model poison the model. One is through the training data sets. You poison the training data set, and that basically poisons the whole weights and biases. Or at runtime, you poison the weights of the models itself. We have tried both, and we have had success across both of these aspects. Now we exactly know, if someone tries to actually poison the weights at runtime using Olama, what all locations are they going to look to find the models? What MD5 checksums are they going to make changes into? Uh, what configuration are they going to peek into? Based on this, we have created security blueprints for Olama, VLLMs, AI Studio, which allows these deployments to be secure by default. And that's a game changing act, right? Like, especially for the on-prem deployments, if an attacker gets its way into the Olama, it's extremely easy to actually change the model weights in the target deployments. So that's where we are coming into play, right? Like, and when we assume
Mhm.
that the attacker is already into the target environment, because it could be through supply chain attacks, it could be through because of internal insider attack, it could be through anything. The other aspect that we are very much interested is using using AI for security, which is yet another topic. I think we'll dig into that
Mhm.
someday later. But that's another
Right.
aspect, that's another dimension that's completely changing the AI security world.
Got it. Got it. Awesome. Now, without taking more of your precious time, we'd love to thank our viewers. They're about 8 to 10, 10 right now to be precise. Really, thank you for your precious time. We hope to continue the series of Thank God It's Thursday, TGIT, with Brian Line, who's one of our CSO at AccuKnox, Chief Solutions Officer. Will be taking up the next session aligned with Gaurav, who's the solutions lead at AccuKnox. We're talking about again all things bits and pieces of AccuKnox, like how Rahul covered one key area of AccuKnox, which was agentic AI security. We plan to cover more on the lines of SaaS, DAST, ISE, software composition analysis, and let's say workload protection, cloud security posture management, etc., etc. So our goal again to in doing all this is to keep sharing what we have in store, and also with respect to the value prop and the use cases that add incredible value to over uh, global customers of AccuKnox. We certainly want to engage more with the community and explore synergies, compare notes, etc., etc. So yeah, that's about it. Yeah, any words of closing thoughts, Rahul, from your side would be great as
Yeah,
well.
no, thank you for doing this, Syed. Very excited to
Yeah,
do this, and looking forward for all the comments, feedback. Uh,
yeah,
we think in another 6 months, every 2 months, things are changing in the AI context. So we are really
mhm,
excited about this, and basically, AI gives us a level playing field as against all the incumbents in the space. So we are excited to be in this space, and I think we could do a great job. Thank you.
yep, yep. Thank you, Rahul. Thank
Thank you.
you once